All right, let's take a look at problem 10, writing these sets A, B, C, D. Here it's written in set builder notation, and we will instead write it in set roster notation using the braces. So first, we want to look at all natural numbers, positive integers that are less than or equal to 20, such that 7 is a factor of x. Okay, so clearly there's only two choices here. 7 has 7 as a factor. 14 has 7 as a factor, but if I go one more to 21, that'd be too big. So that is my set A, 7 and 14. The set B consists of positive integers such that 10 is a factor of x and x is a factor of 40. Well, there are three options there. 10 is a factor of 10 and also 10 is a factor of 40. 10 is a factor of 20 and 20 is a factor of 40. And finally, 10 is a factor of 40 and 40 is a factor of 40. So there are three options for B, so this set has three elements. All right, for C, we're going to do a little bit of arithmetic or algebra down here first. So 2x squared plus x minus 1 equals 0. So that factors 2x, x. I'll have plus 1 here and minus 1 here. So I have x is equal to a half and x equals negative 1. So I want the set of all integers such that this happens. Well, there's only one integer that makes this work, which is the integer negative 1. So that's the answer for C. Okay, D is this other way of writing something in set builder notation, where I have a list of properties here, and then I want for the x's, and then I take 4x plus 1 of whatever these x's are. So I want x's that are rational numbers. 3 times x has to be an integer, and x has to be between negative 8 and negative 6. So that's negative 24 thirds. So x could be negative 23 thirds. X could be negative 22 thirds. X could be negative 21 thirds, which is negative 7. X could be negative 20 thirds. X could be negative 19 thirds. Once I get to negative 18 thirds, I'm at negative 6, and I can't have that because I don't have the equal signs. So there are the x's. And so those are the possible values of x, so I want 4x plus 1, where x can be these five numbers. So I just need to multiply all of these by 4 and add 1. And doing the arithmetic, I get negative 89 thirds, negative 85 thirds. 4 times negative 7 is negative 28, plus 1 makes negative 27. Then negative 77 thirds, and then finally negative 73 thirds. And so that would be writing this set using set roster notation.